Good morning, good afternoon, good evening, good night. It depends where you are in now. Today we will speak uh, in this video about solve uh, problem in Python. So let's go to see the problem. Here is the problem. House prices problem. You are given an array that represents house prices. Calculate and output the percentage of houses that are within one standard deviation from the mean. And he give us a note here to calculate the percentage, divide the number of houses that satisfy the condition by the total number of houses and multiply the result by 100. And I solved it in the spider, and this is the solution. Okay, so first let's analyze, make analysis for the problem. So we need to calculate the output, which is the percentage of houses that are included or within one standard deviation from the mean. So we have here deviation, and we have standard deviation, and we have the mean, and we have also one standard deviation. Let's search about these terms in Google. And we will start by the deviation. What's the meaning of deviation? How to calculate deviation? So, and what's the mean? The mean, which is the average. So, deviation, deviation meaning. Deviation meaning. But here he will give us the meaning in English. We need how to calculate it. Calculate standard deviation calculation. Here is the equation for the standard deviation. From this formula, the standard deviation, which is sigma, equals 1 divided by n, where n is the number of the elements or the number of the items. And here we calculate the summation from I equals 1 to n of the terms. What this term is? X of I minus mu square. Square of x minus mu. Okay? And calculate the summation for every term until the term n, and all divided by n, or times 1 divided by n, and all we calculate its root mean square. This is the standard deviation or deviation. Okay? And mu, which is the mean. When the mean is, it's the calculation, the total summation of the terms divided by the n, which is the number of the terms. This is mu. Let's go back or to our problem. So we need the one standard deviation. What's the meaning of one standard deviation? So go to this article. This graph is very important. So as we know, the terms inside the array or a list or a matrix, we have many elements, and each element has a value, and this value is varying. So this value, this curve is the analogy of these different values. So the maximum value is here, and the lowest is in the terminals. And between the lowest values and the maximum values, there is a range of values from the low to the high. So we have the right and the hand curve. So this is a normal distribution. So we have three terms here: the one standard deviation, and the second standard deviation, and the third standard deviation. The one standard uh, which space or lies in this area, okay, this narrow area. The two standard deviation from this axis till this axis, which is wider, and the third one, which is the largest one, from the last point here or here, this axis, until this axis. So we have three ranges: the narrowest, the medium, and the widest. So the one standard deviation, which is the narrow space, which is called one standard deviation, and calculated by, we calculate the mean, which is the summation of all elements values divided by the number of elements inside an array, then plus and minus sigma. Sigma, which is the standard deviation, which we calculated in this equation. This is sigma, okay? So we have two terms: the lower and the highest. So in this case, we have the mean, which is 13.1, and the standard 1.5. We calculate the subtraction and the addition, and it will be from 11.6 till 14.6. This is the narrowest space. The two standard deviations, we the same equation, but we sum or subtract 2 times standard deviation. The 3 standard deviations, the same equation, but here we add or subtract 3 times standard deviations. Okay? So approximately uh, the two standard deviation around 95 percentage of the list, and the first standard deviation about 68 percentage, while the third about 99%. It differ from one dataset to another dataset. But how to calculate it? With this equation. Equation is very important. I will enlarge this equation to see it. And these equations are very important. In our case here, we need to calculate the one star deviation from the mean. So we will use this equation. In Python, we will not calculate all this formula, this one, which is under the root mean square. We will not calculate this, okay? There is a ready or built-in function which is stand. We will see it here in Spider. I wrote it. So we have here our set of, or data set, which is this array or this list. We will translate it to an array. So first we import the NumPy library and called it as NB variable. And I define the variable sum and the variable c. This is a counter. I will use later. Data, which is a array variable, equals nb.array. I used the built-in function or method array, which is included in NumPy library. And inside it, there is the list. Okay, this list, which is each element is like a price of one house. As we see the problem, we go back to the problem. The problem, which is house prices. You are given an array that represents house prices. So each one is a price of one house. This equals $150,000, and this one $125,000, and so on. So to calculate the standard deviation, which is sigma, this is the standard deviation which we will use here in our equations for calculating the one standard deviation. So we just created a variable std and equals nb.std. std is a function. It's a function in NumPy to calculate standard deviation instead of calculating all this equation of sigma. Then we calculate the mean, which represented by the variable m equals nb dot mean, and the data, which is all this array of this list. Okay, so we calculated the sigma and mu, which are here. This mu, which is the mean, and this sigma, which is standard STD, which is this calculated from this equation. Then we will calculate m minus standard deviation, which is STD, and which is the positive peak, and calculate the m minus STD, which is the negative peak. Okay, and then we need to collect the house's prices, which is included in this range, which is the one standard deviation. This range, which in the graph, this is the narrowest range. This is the one standard deviation from here till here. Okay, we need all the prices inside this range. How to get in the program? Let us see or watch. I will create a loop, for loop. So the for loop, it's counter I, the variable I for I in range. I need the total number of the houses. So I use the len, which give me the length of the array or the size of the array. Len of data and range to range. I will be first 0, then 1, 2, 3, 4 until the n, which is the number or the length of the data. Okay, so if the elements in the data or the array equals 10, so the length or the size equals 10. If it is 20, so the size will be 20. So I will start from 0 till 9. Why? Because I start from 0. Okay, if they are 10 elements, if they are 100 element, so I from I till 99. Okay, so here we start the condition. We will examine the condition. What's the condition? This is the issue. This is the case of this program. If data of I here equals 0, if this is the first element, if the first element greater than the negative value of the range or the space of the one deviation, the one standard deviation, and in the same time it's less than the greater range or the greater the positive peak. Let's see in the graph. Yeah. So I examine here if the price of the house in this area it's greater than the negative peak and less than the positive peak. So it's found here. So I need this one. I need this house. So I can calculate the summation, the prices of these houses by the sum and the number. So I start the summation with 0 upwards. If you see, sum equals 0 and the counter equals 0. This is the counter which counts the number of these houses. C equals Z plus 1. So in this loop, I will examine all the data elements. So I examined here the first element, which is data of 0, and then I will go back after here. I will go back in the loop for loop, and I will be the next value, which I equals 1. So data of 1, then compare data of 1 with the negative peak and the positive peak. If it's greater of the negative peak and same time is less than the positive peak, so I will get calculate it and calculate increase the counter by 1, and so on. At the end, I will here print C, which is the total number of the houses, which is its prices inside the one deviation or the one standard deviation, divided by the total number of the houses, and I will get this percentage. So if I calculate now what the percentage will be, check here in the output, the percentage here is 62.5. 62.5. That means 62.5 of the houses are in the range or the narrowest range, which is the highest prices. Okay, I would like you understand this. This is very important in statistics, especially this program is very important in financial sector. If you'd like to analyze or make analysis for prices for some stock market for company, special company like Amazon, like Microsoft, like Apple, the prices of gold, the prices of oil, Brent oil or Texas oil. You can use this program. This program is very important. All you need is the data set of the company or the stock share of this company, or the data set in the, or in some history, in some period, in 1 year previous, or 2 years, or 5 years, in the previous or the last 12 years, and you can calculate the one standard deviation percentage and the second or the two standard deviation and the three standard deviation, and all these are very important because as you see in the graph, you will get very important percentage which will give you the decision or the how to think accurately to take a decision to buy or sell at this price. I hope you understand this program and how to make a program or design a program in Python for these standards or these statistics, which depend on the mean deviation and the standard deviation and one standard deviation and two standard deviation and three standard deviation. I hope you understood, and if you like this video, like it, share it with your colleagues, and write a good comment inside below, and don't forget to share and support us. Thanks for listening.